Hello everyone, and welcome to another video on the compilation process. In this video I'm going to be going through lexical analysis in more detail, and we're going to be talking about how it works and how it fits in with the compilation process. Before we begin, I need to make it clear that this is a more advanced video and that you do not need to know everything in this video for your exams. Anything that you do need to know I will highlight, but otherwise, if you watch the first part of this series on compilation, that should be enough detail for you for your exams. Now, in that first video, what we covered were all the different stages of compilation, so I've got them here. The first one is lexical analysis. We then have symbol table construction. We then have syntax analysis, semantic analysis, machine code generation, and then finally code optimization. And in this video we're going to be focusing on lexical analysis. So let's have a look at what lexical analysis actually is. So lexical analysis is all about analyzing our lexicon. So we have the idea of a lexicon. And a lexicon, very simply, is just a word bank. It's the language that you are using. So you could think English, French, Spanish, German, any language you want. And what we would do is we would break down that language and look at its individual parts. So it's all about breaking down a language into understandable parts. So in the context of computing, this means we are looking at variables, keywords, constants, fors, loops, ifs, all those kinds of things, and we're figuring out what makes up our language. And what lexical analysis is about is it's about turning source code into a stream of something called tokens. Now, in the previous video I didn't actually talk about what tokens are, but a token, very simply, is a numeric representation of a keyword or an identifier. So let's take a very quick look at a very simple piece of code. I'm going to have for count in range 10. This is a very simple, straightforward line of Python. Now, what lexical analysis will do is it will look at this code one character at a time. So it starts at the F and says to itself, okay, go to my dictionary. So it'll have a dictionary over here of all the possible keywords of the language. So it'll have for, it'll have if, it'll have while, it'll have equals in there, and lots of other definitions. And what it will say is, okay, I've spotted an F. I'm going to go to my dictionary and look for all the all the keywords, starting with F, and it'll go through them all and it'll say, oh, I've got F. There's 4. But is it 4, or is there another one that might also start with an F? So it moves on to the next letter along and it says, ooh, there's an O there. So I'm going to go back to my dictionary and look for all the words, all the keywords starting with F and O. It says, okay, there's one here, it's still 4, but we can't quite be certain. So let's have a look at the next character, and it says it's an R. Well, I'm going to go to my dictionary and I'm going to see all of the words that have F-O-R in them. And then it finds 4. And it's like thinking, okay, so it's probably that, but we're not done yet. Next space, we find an empty space. We find white space, okay? White space. And this is extremely important for lexical analysis because what it says to the compiler is that, okay, this signals a brand new word starting. So that means the definition we have found in our dictionary is the final word we're looking for. So we say to ourselves, okay, I found 4. What is 4? Well, 4 is a key word. So the compiler says to itself, okay, I've found a key word. Great stuff. What I'm going to do is I'm going to give it a number and I'm going to add it to a symbol table. So what it does is it goes away and it draws its symbol table. It says, okay, I've got 4. That's my value, it's a keyword, and I'm going to give it the numeric value 1 in this case. You'll see how this all fits in as we go through. But then we move on to the next one along and we find a C. And we look in our dictionary and we see at the moment we can't find a C. So we move on to the next one, an O, and we keep going, and eventually we'll find out that this does not exist in our dictionary. And the compiler says to itself, ooh, I don't actually have that in my dictionary, so it must be a variable. That's the only possible thing it can be. So what it does is, it adds that word to its symbol table, count, and it says, oh, what type is it? Well, it's a variable, isn't it? So I'm going to give it the keyword var. What number should I give it? Well, it's the second thing I've found in my code so far, so I'm going to give it the number 2. Once it's done that, it finds another space and it says to itself, ooh, well, there's another word coming in now, so let's figure out what that is. So it looks at the I, and it says, oh, okay, so I'm going into my list, and I see if. Well, ooh, it could be an if. So let's keep looking, and it finds N. It says, ooh, well, it doesn't match if anymore, but I have found an in my dictionary. It then moves along and it says, oh, there's another space there. That means I'm done with this particular word. So it says to itself, okay, my word is now in. So I'm going to write in my symbol table. And what is it? Well, it's a keyword. So I'm going to write that. And I'm going to give it the value 3 because it is the third keyword or token that I have found in my code so far. Then I move on to the next one and I find there's an R there. So I go back to my dictionary and I look for all of the words beginning with R. You can think of this like actually searching a dictionary. If someone told you to find a word in a dictionary and they gave you one letter at a time, you'd be able to look through that dictionary and find out which word it is. So after the compiler looks through every single one of these characters, it does indeed find a word in its dictionary called range. And then when it gets to the brackets, it says, oh, okay, range is my next keyword. So it writes it in its table. It knows it's a keyword, and it gives it the value 4. Going back to our code, it knows there's a bracket there, and it will interpret this as part of range, so you don't need to worry too much about whether brackets exist in the language. But once it's in the bracket, it says, ooh, there's a 1 there, and compilers have a very special rule for knowing about variables and numbers. And very simply, a variable never ever starts with a number. And there are reasons for this, but I won't go into that in this video. So what it says is, it looks at the 1 and it says, ooh, this is definitely a number. How long does this number go on for? So it moves to the next one. And it finds out that there's just one more number in there, and it's the number 10. And that's it. So it adds 10 to its list, and it says, well, it's not a variable, it's not a keyword, it is something called a literal. And a literal sounds complicated, but all it is a value that stands for itself. It has no other meaning apart from itself. So other examples of literals could be true, false, 10, 15, Bob, dog, anything. Anything that is just a word, a number, a character, or a true or false value, it's a literal. It doesn't do anything in and of itself. So what I have here is I've currently got 5 tokens created. So what the program will do is it'll say to itself, well, looking at these tokens, I can rewrite this code here as a token stream. And that token stream looks like 1, 2, 3, 4, and 5. And that's all there is to lexical analysis. However, we're not quite done yet. What I'll do is I'll create another program to illustrate these points.